All right, this video is going to go over how to solve rational equations. So a rational equation is one in which you have a rational expression, so a fraction type expression, and the variable you're solving for appears in at least one of the denominators. So you'll notice in all of these that are given here in the examples, there is an x value in the denominator. One thing I want to make sure that we know and kind of recognize here is when that's the case, the denominator can never be 0. So you will have some x values on these types of problems that would be not part of your solutions or not possible parts of your solutions. What I mean by that is, like, let's take this one for example. If I let x minus 3 and say it cannot be equal to 0 and add 3, then I know x cannot be equal to 3. Because if I plug in x equals 3, that would make my fraction a number over 0, which is an undefined rational number. All right, our big goal here is to perform algebraic operations so that all the variables change and appear in the numerator. And we're going to do that by multiplying through by the least common denominator. If I'm looking at my denominators in this first example, I have 2x, I have 3x, and I have 3. If I just look at my numbers for this least common denominator, I want to find the least common multiple of 2 and 3. So if I were to take out multiples of 2 and then take out multiples of 3, we see that that is 6. However, if I only multiply through on every single term here by 6, I would not get rid of the x as well. Since x is to the power of 1 on both of the rational expressions that have an x, I can also say that x to the power of 1 needs to be in my least common denominator. That's what I'm going to multiply each and every term here in my equation by. By doing so, I'm going to move all of my x values into the numerator and turn this rational equation into a linear equation. To step back just a little bit, I do want to make sure that I recognize that x cannot be equal to 0. If that becomes one of my solutions, it's actually not a possible solution, because when I plug in 0, I would then be dividing by 0. So that's the only 0 that, or the only x value, excuse me, that I know that my solution cannot be from the very beginning. So let's try to go figure out what it actually is. All right, when I look here, I have a 2x and a 6x. Those would cancel. Multiplication, division, those would cancel, and I'd be left with 3. So I have 21 minus, here I have 3x and 6x. I'd be left with 2, so 10. And then just the 3 and the 6 cancel here. So I have 22 times 2x, which would be 44x. That gives me 11 on the left-hand side. And when I divide by 44, I get that x equals 11 over 44, which can be reduced to 1/4. All right, let's look and see what happens when we have a binomial in the denominator. I specifically want to look at b here. On b, again, I'm going to list my denominators. I have x minus 3 twice and 2. In this case, there really isn't like a common multiple between those because I have a binomial term. So I'm going to just say that my least common denominator is the multiplication of those two terms. All right, I'm going to multiply this through. making sure that I don't forget any of my pieces getting multiplied by the least common denominator. I can then find the common factors that would be canceled by multiplying by that least common denominator, since I'm multiplying and dividing by the same factor in the top and the bottom. All right, that leaves me with 2x equals 10 minus 1 times x minus 3. Again, I'm going to be able to just solve this like I would a linear equation by distributing the -1 to both of those terms. I'm going to combine like terms by bringing this x over. Adding x to both sides makes 3x on the left-hand side, and then 13 on the right-hand side. I'm going to divide both sides by the coefficient in front of x, and I get that x is the rational number 13 over 3, and I'm just going to leave it in that improper fraction. Notice again at the very beginning, if I would have gotten x equal to 3, that would have caused some issues. However, this is just fine. Let's look at one more example where I have some binomials, but we have some shared terms in our least common denominator. I want to start with a different example first, with just numbers, and then bridge into the least common denominator for the one that's given. For example, if I had 1/2 and 1/5 that I was trying to add to each other, hopefully we would be able to see that the least common denominator, they don't have any common multiples just between the two of them, so 2 times 5 would give me 10. Therefore, I can multiply by 5 over 5 here, 2 over 2 here, and that would be just fine to find the least common denominator, because these here, okay, would need to be turned into a 10. Similarly, if I had minus then like 1/10 or even 3/10, this term right here is already the least common denominator, so I could just leave it alone because 10 is equal to 2 times 5. Let's see how that plays out now in an algebra stance. So the least common denominators that I want to look at in this algebraic expression, in this algebraic equation, I need to recognize that x squared minus 1 can be factored into x plus 1 times x minus 1. It's almost like this is my 2, this is my 5, and the multiplication of the two other denominators gets me the other one, if you think about this back in this equation here. The reason that I point that out is notice I didn't change my least common denominator when it was the multiplication of the other two, because 2 times 5 is 10. That ends up becoming my least common denominator. When you have two factors in your denominators that multiply into the other one, then that one must be your least common denominator. So I'm going to multiply this first term by x plus 1 times x minus 1. I'm going to multiply my second term by x plus 1, x minus 1. And I've ran out of room here, so I'm going to just say is equal to 2x over x squared minus 1, and kind of put it in its own line right there. All right, common factors in the top and the bottom will cancel. So x plus 1 goes away here, X minus 1 goes away here. And x squared minus 1 would then cancel with both terms on the right-hand side. That means on the left-hand side, I have 2 times x minus 1 minus 1 times x plus 1 is equal to 2x. I want to make sure that I distribute this appropriately and then solve for x. So that's going to give me 2x minus 2 minus x minus 1 equals 2x. Combine like terms, x minus 3 equals 2x. Scroll down just a little bit here. And then when I bring x over here, I get negative 3. Must be my solution for x. I then, of course, want to make sure that that's not a 0 of the denominator for any of our pieces here. And it looks like we're good. Here, x can't be equal to negative 1. Here, x can't be equal to positive 1. And then those are the same zeros of that factored difference of squares of the two factors on the right-hand side.